in this series of videos, we are good and ready with our setup of computing, where it will process zeros and ones and gives the output which we wanted. And now, for example, what we exactly process using the computer is data. Generally, data might be in the form of a string or a number or a special character or something. So a number can be represented in binary, and an ASCII standard is used to convert a string into a particular binary. And then characters are also, by having an ASCII standard, they are converted into binary. And earlier computers were used to use assembly language, which is a low level language that used to have a particular operation codes and operands that will perform operation and gives us an output. But the multiple computer organizations has formed a team to solve this problem of having a universal language where it can be compiled on any system and give the desired output which we wanted. So the introduction of all the languages like Fortran, Cobalt, C, C++, all these came into the existence. So generally people will give the instruction and human understandable language, and then once we compile that will convert our code to the low level language, so like a zeros and ones, and the computer will process it and gives the desired outputs which we wanted. So now we are in a phase where we can transfer our human readable code into a machine code, and we are executing the operations. So now the point is, we have a limited computing resources, and then it is using some memory also. So we have limited memory and computing resources, so we need to use this efficiently by using softwares. So the point of algorithms comes in here, because that we need to sort the data. For example, if we want to see the customer who has the largest amount of bank balance, we need to sort the data in a descending order. So all these multiple sorting algorithms like quick sort, heap sort, merge sort, all these sorting algorithms are used for a particular input. So each algorithm has a own advantage of than the other, and then based on our input we'll use the algorithms. And we need to store our data also efficiently. So data structures come into this picture when we see this point. And the general data structures which we have was arrays, linked lists, trees, graphs. All these data structures process the data efficiently. So this here also, for a particular task or an application, a particular data structure is preferred while we are programming. So let's assume that we are good with programming and all our setup is done. Now we need to build a software application like a Microsoft Word. We need to bring millions of lines of code together. So then the advent of object-oriented programming came. So in object-oriented programming, we can make our codes into chunks, and then the code can be reusable when we need particular kind of thing. Generally, multiple teams in a software company build different types of objects or a program, and that can be combined, and then they'll make a universal or a united programming code. And once this during this process there might be some operations that might override someone else's code. So in this particular picture, version control comes into the point, and we need to manage our codes, because a small error by a different team might override my code. So all this version control process comes here. Thank you.